Lesson 6.4, rectangles. All right, but first we must warm up. Graph each quadrilateral. Then determine if the quadrilateral is a parallelogram using the indicated method. All right, let's plot this. -7, -2 is A, -5, 3, B, C is -1, 1, D is -1, -6. Use a straight edge if you can. All right, so in this first example, after you get that plotted, they want me to use distance formula to determine if it's a parallelogram. How would I use the distance formula to prove this is a parallelogram? What do we have to show? Glenn? Not distance won't tell me if they're parallel. If they're congruent. So we need both sets of opposite sides. We need to show that those are congruent. All right, I'm only going to make you do the distance formula one time, okay? Let's all do the distance formula for AB. All right, distance formula reminder. This is a formula, too, that you're expected to know, like, on the ACT. So, it's important. All right, you subtract the x coordinates, and then you square it, and then you add that to the difference of the y coordinates. That's our distance formula. All right, always start within the parentheses. So here I have -7 plus 5 to be -2 squared. Here, -2 minus 3 is -5 squared. Then I square them, so I end up having 4 plus 25 is 29, and you should always get a positive distance, right? All right, the distance of AB is the square root of 29. If you do the same for CD, I'm telling you right now, you get the square root of 29. So, are those opposite sides congruent? You betcha. Is that enough to say this is a parallelogram? No, both sets of opposite sides have to be congruent. Or we could determine if these are parallel, but they want us to use distance formula. Okay, I'll tell you these ones. BC, I got the distance to be the square root of 52. And AB, I got the distance to be the square root of 52. Good news! Those sides are congruent. Is this enough to say it's a parallelogram? Yes. It is a parallelogram because the opposite sides are congruent. Both pairs. AB is congruent to CD, and BC is congruent to AD. That's what we got to show to determine if it's a quadrilateral. We do that actually again today. All right, number 2 is a little different. This one says determine if it's a parallelogram by using slopes. All right, go ahead and plot that. Use a straight edge. If they want me to find the slopes, what am I trying to prove about this quadrilateral?
Parallel.
What are parallel?
The lines.
What's lines?
JK, LM.
The opposite sides. Okay, so JK and LM. Let's calculate those slopes. Now, on a graph, folks, you can just count rise over run. I have a rise of 1 and a run of 1, 2, 3, 5. That slope is 1/5, positive, it's going up. What's the slope on ML? Also 1/5. That doesn't tell me those two sides are congruent. That tells me those two sides are parallel. Parallel. Because they have the same slopes. Who remembers? Raise your hand. I'll be impressed. Who remembers what the slope of vertical lines are? Ooh, Ben. Undefined. Are you going to say? Undefined. So since they have the same slope, those sides are parallel. I know nothing about their lengths. Is that enough to say it's a parallelogram? Yes, that was one of like our 6 cases. If you can show both sets of opposite sides are parallel, then it is a parallelogram. So JM was parallel to ML and KL. JM is KL. And JK was parallel to ML. Okay, that's a review of our parallelograms. Today, we're going to look at a special type of parallelograms. Rectangles. Woo. I know, I love rectangles. Here's my properties of rectangles. Because it's a type of parallelogram, it still holds all those same characteristics of parallelograms. Opposite sides are parallel and congruent. Opposite sides are parallel and congruent. Opposite angles are congruent. Those ones. Consecutive angles are supplementary, like A and D would add to 180. And the diagonals bisect each other. All right, that's true for all parallelograms. These 4 that I already wrote for you, that's true for all parallelograms. What makes a parallelogram a rectangle is 2 things. One's pretty obvious. Anybody think they can guess? What's one thing that's going to make this a rectangle? Ben.
All the angles are 90 degrees.
Has all right angles. Good. Draw those in. Has 4 right angles, which are 90 degrees. Okay, the other one is about the diagonals. The diagonal lengths are the same, are congruent in a rectangle. So this diagonal, AC, is the exact same length as BD. And since the diagonals still bisect each other, this is going to be the same length as this, which is going to be the same length as this, which is going to be the same length as this. Because they're congruent, and the diagonals still bisect each other because it's a parallelogram. So look here. We have a bunch of little isosceles triangles in these rectangles. Look here. See this triangle? Right there. Here's my 2 congruent sides. Isosceles triangle. Meaning this angle across from here is the same as that angle across from the other congruent side. All right, so there's lots of like special little like relationships within these rectangles because they form a bunch of isosceles triangles. Same thing with this sideways one. Whatever this angle is, which is a complement to this angle, add to 90, that's going to be the same as this angle. See that? And since these two add to 90, and so do these two, this one's going to be the same as this one. Okay, so those are all things rectangles have about them. Characteristics, properties. Let's try an example. Quadrilateral EFGH is a rectangle. Go ahead, draw a rectangle on your paper like I did. We got a rectangle here. EFGH. Let's label that. It doesn't matter where you start. You just have to go in order of the vertices. You. Pay attention to me. E. F. G. H. If you go that way. Doesn't really matter where you start. Here's what we know. GH is 6 feet. FH is 15 feet. FH? We're talking about this diagonal. FH. They want me to find GF. Idea. Okay, you're right. Why can we do Pythagorean theorem? This is a right angle, and it's creating a right triangle. Good, Tyson. Pythag, I'm just going to call this X. Pythag says the two legs squared, so 6 would be a leg. X would be a leg. Equals my hypotenuse squared. My hypotenuse is the one across from the right angle. It should be 15. All right, let's do some quick math here. 6 squared is 36. 15 squared is 225. 225 minus 36 is 189. Square root both sides. That's a wind. Yeah, just howling. I'm going to write this as a decimal. 13.7. So GF is 13.7. My units would be feet. Okay. So you can use Pythag in rectangles because of the right angles. Let's try another one. Quadrilateral RSTU is a rectangle. If SU is 6x plus 3, we're talking about this diagonal length, and RT is 7x minus 2, find the length of RT. What do we know about the diagonals of a rectangle? They're congruent. They're the same length. They're the same length. So whatever this diagonal is, 6x plus 3, is going to be the same length as the other diagonal, 7x minus 2. Solve for x. No problem. X is 5. That's not what they asked me to find. They want me to find RT, which is 7 times x minus 2. So now that we know x is 5, RT is 35 minus 2 is 33. Let's go units since we're talking about the diagonal length. Okay, question? Go back. Try another one. Quadrilateral ABCD is a rectangle. If DB is 82, okay, this distance is 82, and DE is 6x minus 7, find x. All right, so we know the diagonals are the same length, but we don't know anything about the diagonal AC. We also know rectangles are parallelograms, so these diagonals still bisect each other. Okay, now careful here. That little EB, that's not 82. The whole segment's 82. So you could do this a couple different ways. You could do, if this is 6x minus 7, EB is also going to be 6x minus 7. So you could do 6x minus 7 plus 6x minus 7 equals the total 82. Or you could say, I know 6x minus 7 is going to be exactly half of that whole segment because it intersects at its midpoint where it bisects it. It's going to be half of 82. This is another way. This is how I solved it, which is 41. Let me get x to be 8. All right, so let me ask you this question. What would the length of AC be? Why?
Because it's the same as 80.
Yes, 82. Diagonals are the same length. So what would EC be? 41. Half of it. Bisects it. Okay? All right, let's move on to some angles. Ooh, look, I threw a fraction in here for you guys. That's promise. Quadrilateral RSTU is a rectangle. That's good news. If the measure of angle RTU, we're talking about this one, RTU, if that angle is 2/3 of x minus 5, and STR, this one right here, is 2 times x plus 3, find x. Ideas of how we could set up an equation. Gwen?
2x plus 3 is 2/3 x minus 5 equals 90.
Correct. Why?
Because all rectangle angles are 90 degrees.
Perfect. I hope the video heard you say that. That was perfect. She said add those to them to 90 because all rectangles have 4 right angles. That's going to be 90. All right. Fraction freaks. Let me show you an easy way to solve this. I'd probably add these together. Not the variables yet, because it has a fraction. So 3 and -5 is -2. An easy way, instead of dealing with like mixed numbers or improper fractions, is just times both sides of your equation, and you can do this as long as you times everything by the denominator here, which is 3. Watch what happens. 3 times 2x is 6x. 3 times 2/3 is 2. Or cancel these out. We get 2x. Don't 3 times the 3 to this -2. 3 times 90 is 270. That's personally how I would do it. Gets rid of the fractions. And then I can just solve this equation like normal. Add over the 6. Divide by 8. Now you do get a decimal, and it's 34.5. So it's okay to write it like that, 34.5. It's okay to write exact decimals like that. If you want to leave it as an improper fraction, it's 69/2. That's fine too. I don't love mixed numbers, but I would accept it if it was right. Okay. Another one with some of the angles. This one's fun. Quadrilateral ABCD is a rectangle. If measure of EBC is 53 degrees, find the measure of EBA and BEC. All right, I'm going to start with the green one because I know the red and the green angle have to total what? 90, right? So EVA would just be 90 minus 53. Since it's a rectangle, that's a right angle. $37. Okay. Now to find that blue angle, idea.
It's an isosceles triangle, so the other corner is also 53 degrees.
Beautiful. Okay, hold on. You're good. I just want to show them. You're looking at this triangle, right? Tyson? You're looking at this blue triangle? How do you know this is isosceles?
Because the AC and BD are always congruent.
Yep, the diagonals are congruent and they bisect each other. Right? So actually all of these are the same. Okay, good. So you said if this corner is 53 degrees across from this congruent side, this corner is also going to be 53 degrees. Good. Okay, keep going, Tyson. What were you saying?
So it would be 52 plus 53 equals 106, so 180 minus 106 equals 74.
Good. So now he's like, hey, we have a triangle here that has to total 180 degrees. So for BEC, he did 180 minus 53 plus 53, or like double 53. And you got 106?
74 degrees.
Oh, 74. Why did I think 106? 74. I don't know where I got 106. Okay, 74. Good job. All right, you don't have to write this down. Just look up here for a second. Along with Tyson's thinking here, we can actually figure out every single angle here. So let's look at this isosceles triangle. If this is 37 degrees, what's this angle going to be? 37. And if these are complementary, what's this angle going to be? 53, right? So those like opposite sides of the diagonal, those will be congruent. Okay? Because they're complementary and we have all these little isosceles triangles. Good. All right, next one here. Max is building a swimming pool in his backyard. He measures the length and width of the pool so that opposite sides are parallel, as shown. He also measures the diagonal of the pool to make sure that they are congruent. How does he know that the measures of each corner is 90 degrees? All right, well, because he measured the opposite sides to be parallel, we know this is a parallelogram, right? The pool is a parallelogram. Because both opposite sides, both pairs of opposite sides are parallel. So now to answer his question, would each of these corners be 90 degrees?
Yeah.
Why?
Because they're all parallel.
Yeah, but in a parallelogram, I could have something that looks like that, and these aren't 90 degrees. What makes each corner 90 degrees?
If they were congruent to the
The sides?
wall. Yeah, if they were.
Not even that either.
No?
I could have this, right?
I don't know.
Good guesses, Jessa?
Diagonals are congruent.
The diagonals are congruent, which makes it what? A rectangle! Nice! Since the diagonals are congruent, good job, Jessa. It is a rectangle. And since it's a rectangle, all angles are 90 degrees. That felt like a little mini proof. Okay, I like that. Good thinking problem. All right, we have a couple coordinate plane ones to end this. So because a rectangle is a type of a parallelogram, a lot of the times when we're asked to prove if something's a rectangle, we first just make sure it's even a parallelogram. Because if it's not a parallelogram, it can't possibly be a rectangle. So we can save ourselves a lot of time if we can prove whether it's a parallelogram or not to determine if we even need to check if it's a rectangle. Okay? So take a look at an example like that. Quadrilateral, JKLM has vertices here. Go ahead and plot those. They want us to determine whether it is a rectangle, and they want us to use the slope formula. So they want us to use slopes. Okay. So the first thing you're going to do is you're going to find the slopes of all the sides. And then you're going to ask yourself this question. Are the opposite sides parallel? If they are, then that means it's a parallelogram. If they are not, it's not a parallelogram, and therefore it can't be a rectangle. Let's say it is a parallelogram. Let's say the opposite sides are parallel. Then we're going to ask ourselves to determine if this is a rectangle. These would have to form a right angle, meaning they'd be what? Perpendicular, meaning they'd have what kind of slopes? Opposite, reciprocal. So that's what you would check next. Oops. You would check, are the consecutive sides, that just means like two sides, perpendicular? If they are, then we can conclude it's a rectangle. But again, we have to make sure it's a parallelogram first. So let's try that with this example. I'm going to pick these sides. I'm going to pick JK and ML, and I'm going to calculate their slopes. Okay, I'm going to count rise over run. So I see it's going down 8 and to the right 2. So JK has a slope of -4. You don't have to pick these two sides, but I did. And then I count M is going from M to L is going down 8, but to the right 3. Uh-oh. Are those opposite sides parallel? No, they have two different slopes. So already it's not a parallelogram, so can it possibly be a rectangle? No, you don't have to go any further. You don't have to check if they're perpendicular or anything like that. You just saved yourself a lot of times. This isn't even a parallelogram, so no, it's not a rectangle. Because JK is not parallel to LM. And how you can write that in math language is by putting a slash through that parallel. Not parallel, just like you do with not equal to. Okay, that's how you have to do it with slopes. Make sure the opposite sides are parallel. And obviously, just find the slopes on both sides. Make sure the opposite sides are parallel. If they are, make sure the consecutive sides are perpendicular, opposite reciprocals. Okay, you'll try some in your homework. All right, then our other case scenario is we can use distance formula. Okay. So same idea. We want to know if this quadrilateral is a rectangle, but this time they want us to use distance formula to verify. All right, let's go ahead and plot this now. 4, 3. 4, -2. -4, -2. -4, 3. All right, to do this, first you're going to show that it's a parallelogram. Oh no. So the way we show this as a parallelogram using distance formula is we show the opposite sides are congruent, just like we did in the warm-up. All right, the nice thing about this one, the opposite sides are nice, easy, horizontal, and vertical lines. So we don't even need distance formula on this one. What's the distance of AD? 8 units, good. What's the distance of CB? 8 units. That does not tell me those sides are parallel. I'm not checking their slopes. That tells me those sides are congruent. Now I have to show both sets of sides are congruent. So now let's check the other ones. And these are nice, easy vertical ones. All right. What's the length of CD? 5. What about AB? Also 5. Are those sides congruent? Yes. All I've done right now is show it's a parallelogram. To determine if it's a rectangle, I'm not going to check for perpendicular slopes because they want me to use distance formula. So I'm not going to try and prove there's right angles. Any ideas of how I can use distances to determine whether this is a rectangle? Ooh, Matthew, idea?
AC.
The diagonal length has to be the same as? Nice, guys. Second, show that it's a rectangle. By finding diagonal lengths. Okay, now what's nice about rectangles is you can use Pythag if you want. You don't have to use distance formula. You can if you want. If you love distance formula, you can use it. But look here. Let's say I'm finding AC. I know this is 8 units. I already found this. Now this is 5. So to find this right here, I could do Pythag. I could do 8 squared plus 5 squared equals, I'll just call that D for diagonal, equals my diagonal squared. If you want to do this, you get the square root of 89. The same answer as if you would have done distance formula using A and C as your coordinates. All right, so I'm going to tell you DB is also a distance of square root of 89. Is this a rectangle? Yes, because the diagonal lengths are congruent. And we already proved it's a parallelogram. So yes, it is a rectangle. because my diagonals are the same. They're both the square root of 89 units. Are rectangles anybody's favorite shape? Well, what's your favorite shape?
A nonagon.
A what?
A nonagon.
A nonagon? Cool. You guys just love triangles from chapter 5, don't you?
No, I switched to
Okay, one last thing. I have this little quadrilateral family tree that we're going to fill out as we learn more about quadrilaterals. What's a quadrilateral? 4 sides. Any polygon with 4 sides is a quadrilateral. That's the top of this family. Just has to contain 4 sides. What we've looked at now are a special type of quadrilaterals where the opposite sides are congruent and parallel, both sets, and those are parallelograms. It's a type of a quadrilateral, a special type. And today we looked at a special type of parallelograms that still have opposite sides that are congruent and parallel, but now they have 4 right angles, which we classify as rectangles. And their diagonals are the same length. Keep that in a safe spot. We're going to fill that out as we learn more about quadrilaterals.